Hey yo, listen up! You're doing this the wrong way. Why put all that effort when you can do it for half the force? So, hey, what is up, guys, and welcome to the Spotlight. Now, what if I told you that there was something which you guys do wrong, even if you know how to do it right? Well, yeah, not consciously, obviously. Now, what if you had to lift this load? It has about 800 milliliters of water, so the weight is around 800 gram force, and you needed to lift this bottle with this string, and you can have the string as long as possible, and you can support it in as many ways as you want, but you need to lift it by applying a force which is lesser than the weight of the bottle. So, well, if you read the title, this video was about pulleys. So, of course, the answer should be around pulleys, right? But no, you don't get a pulley. You have to do it with the stuff you have. That's it. That's a challenge. Now, let me provide a hint. You can support it against as many supports as you want. Now, if you know pulleys well, I guess you have the problem solved. But for those of you who don't know how to use it, let's go over some things. What we could do was first use a fixed pulley, right? So for that, we can just make the string fall with the other end falling on the other side of a rod or a beam, or or any support. But then my challenge of actually using less force to lift the load is not yet complete, right? And if you know pulleys, you know there's a way to half the force, but a fixed pulley does not do that. So what we use is called a movable pulley. Now, if you don't know what it is, or you know partially what it is, but you're not sure of that, well, hold on. Now, a movable pulley gives us what we call in physics a mechanical advantage. So what is mechanical advantage? Generally speaking, it is how heavier a load can be lifted by applying the same force. So a machine with a higher mechanical advantage helps us lift a heavier load or transmit our force which we apply as effort for a greater load. Load is amount of force which we want coming on the other side of a machine, and effort is the force we apply in doing some work. So mechanical advantage mathematically is written as a ratio of load to effort, since if we are able to lift, let's say 5 kgs by applying only 1 kg of force, now of course kg is not a unit of force, just generally speaking, if we are able to lift a 5 kg block with only applying 1 kg force, that means we have a mechanical advantage of 5. Now the thing is that this force does not come out of the blue, since you cannot just make energy, right? So there's a catch. The displacement is often in the same fraction less, and this is actually represented by a quantity known as velocity ratio. Well, now you know what a movable pulley does, but how does that solve the problem? You don't have a movable pulley. So what would help is knowing how it does what it does, right? So a movable pulley essentially helps us bend the string around and then halves the distance by which we pull the load upwards, such that the force we use to pull the load upwards is actually transmitted on the other end too. So if I were to attach one end of the string to a support, let's say, and then pull the load by pulling the other end upwards, and then the load is there in the bendy bend, okay, and it slides, that would actually do what a movable pulley does without actually using it. And that would also act as a machine, and it would give us a mechanical advantage of 2. But since we are not allowed to make energy out of the blue, since work done is actually force times displacement, and we actually multiplied the force on the end of the machine, the displacement gets halved. Therefore, energy is conserved. And this halving of the distance is actually dubbed in velocity ratio, the thing I talked about before this. So what is velocity ratio? Velocity ratio is actually a ratio of the velocity of the effort. That means let's say I'm pulling the string with a velocity, that velocity to the velocity of the load with which it is moving. So essentially the load moves with half the speed. So I have to actually pull more for it to go that distance which you wanted. Now just remember this, mechanical advantage and velocity ratio are just shitty terms which people just made up to classify things. Think of them as convention. So now let's look at how to actually use it. So what you can see is I'm holding one end of the string and then I'm attaching the other end to my beam, and then I'm pulling the load, and you can see the load which is actually looped around the string, so it actually slides along the string as I pull it upwards. So now someone even remotely sane would ask this: if we can achieve what a pulley does without actually using it, then why use it? So we need a pulley because of this: efficiency. Hey,
Quadrant. It's a weird word when you think about it. Quadrant. See, now it doesn't even sound like a word.
So what a pulley does in helping us is that it reduces the friction between strings. So as you can see, if you look closely at the spring balance, effort which I need to apply is still not half that of the weight of the bottle, which was 800 gram force. Well, that is because some of the effort is needed to overcome the friction between the strings, and that is where the movable pulley comes in. The movable pulley has the rotating thing, the rim, and that actually helps us reduce the friction, virtually minimize it, so that we can actually get the maximum amount of efficiency. Efficiency is mathematically work output by work input. So if I applied 1 kg force on the input side of the machine and I was supposed to get 2 kgs but I only got 1.5, so that means the efficiency is not maximum. Okay, and efficiency is never maximum in a real life scenario. It's only maximum in an ideal case. And efficiency is, well, as you all know, is written in percentage-ish form, yeah, whatever it is. So if we multiply 100 with the fraction, so it is work output by work input into 100. So now you know what a machine is, the various quirks of them, and that's actually chapter of machines for the class 10, basic high school physics. And this is not a substitute for your book, for your classroom teaching, because, well, you have to study the irrelevant things too. Yeah, and I hope I was able to make it fun for you. And yeah, yes, I know. I haven't uploaded, I know, but well,
like, share, subscribe. That's all you gotta do. You gotta do what you gotta do, man.